Alright, let's take a look at example 7. It says determine two integers that have the following relationships. 14 more than twice the first integer gives the second integer. The second integer increased by 1 is the square of the first integer. And the question asks us A, to write a system of equation that relates to the problem, and to B, solve the system algebraically. Alright, this is a translation problem. Each sentence will give us an equation. It says 14 more than twice the first integer gives the second integer. So twice the first integer, there's 14 more, gives me the second integer. And the second integer increased by 1 is equal to the square of the first integer. There are two equations. The first one represents 14 more than twice the first integer gives the second integer. The second equation comes from the second sentence. The second integer increased by 1 is the square of the first integer. Alright, B asks us to solve the system. Again, it's really nice. We've got y already isolated in the first equation, so we're going to use substitution, putting equation number 1 into equation number 2. So instead of writing y plus 1 equals x squared, we're going to write 2x plus 14 plus 1 equals x squared. Alright, remember, this was y from the first equation. So we get 2x plus 15 is equal to x squared. This is a quadratic function, so we need to make it equal to 0 in order to effectively solve it. Oh, and thankfully, to solve this quadratic equation, I don't have to use a quadratic formula because I recognize that I can factor this as x minus 5 and x plus 3. Right? The first factor gives me a solution of x equals 5. The second solution gives me a factor of x equals negative 3. Right, now that we've found the x coordinates, we need to figure out the y coordinates. And so we've got x equals 5 and x equals negative 3. We're going to use the linear equation 2x plus 14 equals y. So 2 times 5 plus 14 equals y, which gives us 28 is equal to y. And for the second one, we get 2 times negative 3 plus 14 is equal to y. That's 14 minus 6, which is 8. So the integers are 5 and 28, or negative 3 and 8. Alright, so it's a simple system. The key to solving it lies in translating the sentences into the correct equations. Let's take a look at example 8. Alright, we'll now take a look at example 8. It says, suppose the crate's height above the ground is given by the following two equations. Alright, so let me give you a little bit of the backstory here. We've got an airplane flying by, and he's dropping supplies to refugees on the ground, and he throws a crate out the window. The height of the crate, falling without a parachute, so this is falling without a chute, is given by negative 4.9 t squared plus 900. And the height of the crate falling with a chute is given by negative 4t plus 500. A says, how long after the crate leaves the aircraft does the parachute open? Express your answer to the nearest hundredth of a second. Alright, so what they're asking us to do here is to figure out when the heights of the two equations are the same, because that's when the parachute opens. So we need to solve this system. We're going to use substitution because h is already isolated. And so we get negative 4t plus 500 is equal to negative 4.9 t squared plus 900. We need to get, this is a quadratic equation, so we need to make it equal to 0. I'm going to move everything to the left-hand side. So 4.9 t squared minus 4t minus 400 is equal to 0. The odds of us being able to factor this equation are pretty slim, so we're going to use the quadratic equation to solve it. So the quadratic equation, t is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. So we get t is equal to negative 4 plus or minus the square root of 4 squared minus 4 times 4.9 times negative 400, all divided by 2 times 4.9. Alright, simplifying, we get 4 plus or minus the square root of 7,856 divided by 9.8. So we get t equals 4 plus or minus 88.63, 4079 divided by 9.8, which gives us two possibilities. 4 subtract 88.634 divided by 9.8, which gives us a value of negative 8.64, or t is equal to 4 plus 88.634 divided by 9.8, which is equal to 9.45. Clearly our time has to be positive, so after 9.45 seconds the parachute opens. Alright, let's take a look now at B. It says, what height above the ground is the crate when the parachute opens? Express your answer to the nearest meter. We figured out the time is 9.54 seconds. We now need to figure out the height. I'm going to use the linear equation because that's far simpler. Negative 4t plus 500. So we get negative 4 times 9.45 plus 500, which gives us a height of 462.2 meters. Alright, and the final is C, verify your solution. Well, we should probably check it in the falling without a crate solution. Let's see. In equation 1, the right hand side is negative 4.9 times 9.45 squared plus 900. We get 462.4, which is approximately what the left hand side should be. Alright, we're out by 0.2, but that's because we have some rounding errors. So it looks like our solution is correct. Alright, so let's review. What did we do here? We had to figure out how long after the crate leaves the aircraft does the parachute open. So we figured out the point of intersection of the equation for the crate falling without a chute and falling with a chute. Alright, that tells us when the parachute opens. Alright, we couldn't factor, so we had to use the quadratic formula to figure out it took 9.45 seconds for the parachute to open. We figured out that the height was 462.2 meters using the second equation, and then we verified it using the first equation. We came up with the same value in both.